Good morning, dear friends. Today we will study the sum number 2.19 as we continue our work. Previous lecture we calculated the sum 2.18, the example number 2.18, and today we will calculate the sum number 2.90. It is example sum. It is 2.9. If one of the two electrons of S2 molecules is removed, we get a hydrogen molecular ions S2 plus. Here, when the electron is moved, it is converted into the ions. Okay, that is a H2 plus. Okay. In ground state of H2 plus, the two protons are separated by roughly 1.5 angstrom. That is a protons. It is separately 1.5 angstrom. Okay. Now the electron is roughly 1 angstrom from each proton. Here the electron. It is roughly 1 angstrom from each proton. Okay. So, determine the potential energy of the system. Specify your choice of the zero of potential energy. So we have to find out the potential energy of the system. So that is very simple. It is in that there is no external electric field is applied. So that is we will make the pair. So V is equal to otherwise U is equal to U1, 2 and 3. Okay, U12 plus U13 plus U23. Okay, there is a pair of 1, 2, 1, 3 and U23. So that is very simple. 1, 2 means there are the two protons. E square 1.5 to 10 raised to minus 10 plus U13 electron and proton. Here the minus sign because E plus and E minus. So K is square minus, it is 1 angstrom, 1 into 10 raised to minus 10. Okay. Now that is the, after that it is 2, 3. So minus K is square, 1 into 10 raised to minus 10. Okay. Now we calculate K is square, take the common. U is equal to K is square. K is equal to 9 into 10 raised to 9. E square is equal to 1.6 into 10 raised to minus 19 of whole square because here the whole square. So 1.6, the whole square is 2.56. Okay, here the minus 38. Okay, now 1 into 10 raised to minus 10. Here the 10 raised to minus 10, it is common, so here 1 upon 1.5 minus 1 upon 1 is equal to 1, here the 1 upon 1 is equal to 1. Okay, so 10 raised to minus 10, it is 10 raised to, when we take the numerator, so it is plus sign, so 9 into 10 raised to 19 into 2.56 into 10 raised to minus 38. Here 1 upon 1.5 minus. So these calculations gives us the answer is that U is equal to minus 30.7 into 10 raised to minus 19. Okay, 30.7 into 10 raised to minus 19. We convert into the electron volt. Here the joule and volt both we will write So to convert the electron volt, U is equal to minus 30.7 into 10 raised to minus 90 and divided by 1.6 into 10 raised to minus. This is converted into the electron volt. E multiply with E and divide with A. Here the value put substituting in this equation. Okay. So this answer is minus 19.2 electron volts. Okay. Therefore, the potential energy of this system it is minus 19.2 electron volt. Okay. Yes. So after that, the next topic is that the potential energy of the dipole in external field. Okay. So this is the most important topic, and it is asked in exam because it is very most timely. Okay. So this sum you will do. Potential energy of dipole in electric field. Okay. Potential energy of dipole in electric field. Here the uniform electric field that is the, and the nature of the dipole, it will remain the parallel to the electric field. Okay. At this time the resultant force is always zero, torque is not applied. Okay. When we move from the uniform electric field and it is parallel to the electric field, when we move at this time torque will be applied. Here the dipole is making with the angle theta with electric field. Here the minus q, here the plus q, and here the minus q. That is the force is minus qb and here the force is plus q. Okay. So if it is making the angle with a, that is theta, so torque will be applied. Okay. The perpendicular distance is that we decide in the first chapter. This angle is, we can say it is theta, and the perpendicular distance is here the distance between the two charge, it is 2a. Okay. So work done to move dipole in uniform electric field if we want to move the dipole in uniform electric field, there is external torque will be applied. Okay, there is an external torque will be applied, and we have to done some work to move the dipole in the parallel and uniform electric field, and this work is W is equal to, we can write, this is the integration of tau of theta into d theta. Tau is equal to function of theta, so we can write it as tau of theta into d theta. Here by nature that is a, it is in parallel to the electric field, theta is equal to 0, but we can write that is a theta 0. and we remove from the electric field, and that makes the angle with the electric field, it is theta. So we just move theta 0 to theta. Okay, here we can write the tau into theta because work is equal to force into displacement. So here just I take the tau in place of force, and here the d theta is equal to angular displacement. So it is in place of the displacement. Okay, so here we can write W is equal to tau theta into d theta. Okay, tau is equal to, we know that in chapter number 1 we studied, that is a tau is equal to Pe sin theta. Tau is equal to what? Pe sin theta. Substitute this value here, the we can write it is tau external. Okay, so W is equal to integration Pe sin theta into d theta. Here the theta is 0. Okay, Pe constant, take the outside, Pe theta sin theta into d theta. Okay, the integration of sin theta, it is minus cos theta. That is theta 0 theta. Okay, now upper limit and lower limit we substitute in place of theta. So Pe minus cos theta, that is theta theta, minus cos theta 0. Okay, minus plus, so here we can write it is Pe plus cos theta 0 minus cos theta. Okay. If theta 0 is equal to, if we take, this is the theta 0 is equal to pi by 2. So W is equal, yes, this work is called the potential energy of the dipole in the electric field. That is the potential, and we know that if we work done to electric charge from bring to the from infinite distance to the point, we have to work done, and this work is converted into the potential energy. Here the simple, if the dipole move from the electric field, that is some work done, and this work is Pe, W is equal to Pe cos theta 0 minus cos theta. Okay, here the theta is equal to 0, so here the cos pi by 2 is 0, so the potential energy is equal to minus Pe cos theta. The energy, it is scalar quantity, so U is equal to P dot E, that is minus. The potential energy is minus because here we done the work against the electric field, so here the potential energy is minus. Okay, there is some loss of the energy because when we keep the dipole from the parallel to the electric field, at this time there is some heat energy is produced, so some loss of the potential energy in this system. Okay, yes, so that is a minus sign, so that we have to work done against the electric field. Okay, so it is very most important question that is asked in board exam in 3 marks. Okay, it is very simple. That is mathematical work, and mathematical work we have to remember that W is equal to integration tau external theta into d theta. Tau is equal to torque and d theta is equal to angular displacement. Okay, and that is tau is equal to P sin theta. Substitute in this equation. After that, integration of sin theta is equal to minus cos theta. Put upper limit and lower limit in equation. So here, and last we have to take in naturally theta 0 is equal to, when when the theta is 0 is equal to pi by 2. So u is equal to minus p cos theta and u is equal to p dot e. Okay, when theta is equal to 0, when theta is equal to 0, that is u is equal to minus pe, because cos theta is equal to 0. And at this time we can say the potential energy u is maximum, that is minus p, and that is, we can call it is u is equal to maximum when theta is equal to pi by 2. So u is equal to 0. Okay, and theta is equal to pi, then u is equal to plus q, and that is the minimum potential energy. Why minimum potential energy? We worry about the plus sign, and always we can say the plus sign gives a maximum, but according to the potential energy it will always in minus. Okay, so we can say that is a minus sign shows that it is maximum potential energy, and the plus sign shows that it is minimum potential energy. Okay, because we have to work done against the electric field. Okay. Now we calculate the sum that is dependent on this topic, and it is the illustration sum, and it is example number 2.6. Illustration 2.6. Previous sum, it is in the exercise sum, so remember this. Here a molecule of the substance has a permanent electric dipole moment of the magnetic moment of magnetic 10⁻29 coulomb into meter. A mole of this substance is polarized by applying a strong electric field of the magnitude 10⁶ volt per meter. Here the dipole moment of the dm, that is called dipole moment of molecules, it is 10⁻29 coulomb into meter. So we have to just calculate that, we have to find the total dipole moment, and for the find total dipole moment we know that in 1 mole substance, that is the number of molecules it is Na. Na is equal to 6.023 into 10⁻23. Okay, so here the total number of the molecules in the 1 mole substance, and it is 6.023 into 10⁻23, and the dipole moment of each molecule it is 10⁻⁻29. So the total dipole moment of system is very simple, that is Na into small p. This is the small p. Okay, and here just we get the p dash. So p dash is equal to 6.023 into 10⁻23 and multiply 10⁻⁻29. Okay, so 6.023 into 10⁻⁻ 6. Okay, that is coulomb into meter. We have to first find the total dipole moment, because there is, this dipole moment is given the 1 molecule dipole moment, and we know that the 1 mole substance, the number of molecules it is 6.023 into 10 raised to 23. Now the electric field is given, E is equal to 10 raised to 6 volt per meter. The direction of the field is suddenly changed by the angle, it is 60 degree. The theta is given 60 degree. Okay. Estimate the heat released by the substance in aligning its dipole along the new direction of the field. For simply assume that the 100% polarization of the sample. Polarization means all the dipole, it is arranged to the parallel to the electric field. That is called the 100% polarization in the direction of electric field. Okay. So here the potential energy, we know that U is equal to minus PE cos theta. Okay. Here we use this sign P dash. So minus P dash is equal to 0.623 into 10 raised to minus 6. E is equal to electric field is given 10 raised to 6 and cos 60. So minus 6.023, here the cancel, cos 60 is equal to 1 by 2, and that is minus 3 point something. Here it approximately, that is 3 joule. Okay. So change in the, yes, we have to, here we have to find out that estimate the heat release by the substance is aligned its dipole along the new direction. Here that is, first of all, it making the angle is that इसमें यहाँ पे UI is equal to, first of all it will be parallel to the electric field, and that is UF, and we have to find out the UI. We have to find out the UI. UI is equal to minus PE cos 0 degree. मतलब पोलराइजेशन हो जाएगा, पोलराइजेशन है तो वो इलेक्ट्रिक फील्ड के पैरेलल होगी. सो वी हैव टू टेक द इनिशियल पोटेंशियल एनर्जी एंड इट विल बी थीटा इज इक्वल टू 0 डिग्री. सो हियर द माइनस P इज इक्वल टू 10 raised to 6.023 into 10 raised to minus 6 is equal to 10 raised to 6 into 1 minus 6 joule. Okay. So the potential difference delta U, it is causing the heat, produce the heat energy. That is the heat energy. And this gives us UF minus UI. UF is equal to what? Minus 3 and minus 6. That is delta U is equal to, it will be, okay. So there is a loss in the potential energy, and this must be the energy released by the substance in the form of the heat in align its dipole. And that is we give the dipole from the electric field, that is potential energy, some type of the potential energy converted into the heat energy, and that is a plus 3 joule. Okay. Now the electrostatic conductor, and after that the topic is electrostatic shielding. We will study in the last, and after in next lecture we will study about the capacitor. There is a new topic and we will go further with the capacitor. Okay, thank you very much.